All right, our next concept here is similarity transformations. And so another name for that is called a dilation. Last concept, we talked about rigid transformations where we had translations, reflections, rotations, and the shape and size didn't change. In a dilation, the shape will stay the same, but the size changes. So we have two different dilations. The first one is a reduction. And as you can guess, it gets smaller. So for example, if I had a reduction of 1/2, I would split all of my shapes in half, all of my coordinates in half. So A prime would be at 1, 2. B prime would be at 2, 1. And C prime would be at 2, 2. And basically I have a new shape, A prime, B prime, C prime, that is half the size of my original triangle. The other type of dilation would be an enlargement. And so an enlargement would be like if I were to double everything. So I've got triangle DEF here. If I were to have an enlargement and I double everything, D would be -2, -2. E would be -6, -6. And F would be -2, -6. And so I'd have a new triangle, same shape, but just enlarged. And so those are my two types of dilations, either an enlargement or a reduction. So it's either going to get bigger or it's going to get smaller. Mainly in our coordinate plane, we're going to use the origin, or 0, 0, as our center of our dilation. And then your scale factor would be how much it grew by or how much it was reduced by. So in this one, our reduction, our scale factor would be 1/2 or 0.5. I basically just divided everything by 2. In my enlargement, my scale factor over here would have been 2. So that just tells me how much it's going to grow by. And I'm always multiplying, I'm always doing that. And it's pretty straightforward when we're looking at we're using a dilation in a coordinate plane. So just real simple. Really the big thing you need to know from here is just that you're multiplying by your scale factor. So let's just say I have coordinates. I have x, y, and z. If I had the coordinate x at 3, 4, and I had a dilation with a scale factor of 3, that tells me that it's going to be an enlargement, okay, and I'm going to multiply it 3 times. So x prime, I'm just going to go 3 times 3 and 4 times 3, because that's what my scale factor was. So x prime is now 912. So as you can see, it's going to be much larger, 3 times larger. Okay, next one, if I had point y and I had a dilation with a scale factor of 1.5. You can have decimal versions, so I'm just going to do the exact same thing. 5 times 1.5 is going to give me 7.5, and -1 times 1.5 would give me -1.5. So my y prime would be 1.5 times bigger than my original y. So those are both enlargements. A reduction then would be if I had a dilation with a scale factor of something less than 1. So earlier I had used 1/2. I could use 1/4. So let's say my scale factor is 0.25. What is z prime going to look like? Well, 0 times my scale factor, 0.25, would still give me 0. So that won't change. But then 8 is going to get smaller. So I'm going to take 8 times 0.25, or 8 divided by 4, and my new z prime is 2. So when my scale factor is smaller than 1, it's a reduction, and my z prime, my new point, would be much smaller than my original. So dilations are pretty straightforward. We're just multiplying our coordinates by the scale factors, and if it's a reduction, our new image is going to be smaller, and if our scale factor is greater than 1, it's going to be an enlargement, and our new image will be larger than the pre-image. So pretty straightforward here with similarity transformations. Our shapes are now similar instead of congruent.